Hello, we are the Microsoft Group. I'm Zachary D'Ambrosio.
My name is Alan Pulis.
I'm Ben Weller.
I'm Eric Van Aspen.
I'm Akil.
Our project is the Pizza Oven Monitor for preventive and reactionary maintenance. So just a quick overview of the company we're working for, Microsoft, in case you don't know anything about them. They make Windows software, Dynamics, which is a business analytics tool, and Azure, which is a cloud-based computing tool, and Office 365, which has your things like Windows and Excel and all that stuff. Within Microsoft itself, our mentor is Dave Frostley, who works within Dynamics 365. So moving on to what our actual project is, it's proof of concept, and that's about connecting various technologies and seeing how that goes. And so the scenario that we're using to test that is pizza ovens that are internet connected. So they send their data somewhere, and you use that to go through the data and find red flags for preventative maintenance. So you know, like certain things about the oven. So maybe the temperature is rising slower. Maybe that's a sign you need to do something about it. So the big problem that this causes is you're going to want to move the data around a lot. You're going to want to provide it to different people, and you're going to want to always have access to it so you can keep making your red flags as accurate as possible. So that causes problems of moving data around a lot. You might get some inconsistencies, you might cause some errors, and if you're moving it around like that, that's going to be trust issues too, and you want to avoid those things. So what we want to do is we want to find a solution that allows us to tackle those problems, make sure it's scalable, because with a lot of components you might end up not letting it be scalable, which is obviously something you want to avoid. And we also want it to be accessed through a mobile application for like the manager or whoever needs the information about the oven for ease of access. So for our solution itself, what we decided the best option was we wanted to use largely based around using Azure, and what that provides is it provides a number of options for like the notification hub on Azure and the IoT hub, which allows you to easily integrate things like our mobile aspect and the IoT aspect right into Azure. And then for the data problem, we decided the best option was to use, a blockchain, which I'll let Eric go into more about why that works really well, but basically it solves our problems of trust and access. And then if we look at our diagram, you can see that coming out of the Raspberry Pi, which is the IoT device, it has a hot path and a cold path. The cold path is the blue one, and that represents non-consistent flow of data, and also where you're going to be storing all your data. And the hot path is more consistent flow, and it's much quicker, and it's directly to the mobile client, so that way they can get their information as quickly as possible. So as you can see, it kind of covers both if you need to tell the mobile client immediately and storing the data so you can go over it later. With that, I will pass it on to Ben to talk about our schedule.
So regarding our project, Sprint 1 started off, met everybody, met Dave, talked with him about the project. At this point, we weren't really sure where the project was going to go, and we knew we needed to pick a blockchain. So we picked Ethereum initially. We switched that later on. I'm sure Eric will go into some reasoning behind that. That was pretty much Sprint 1. Moving on to Sprint 2, so the second month, the IoT portion was added. So Akil initially wasn't a part of the team, and so he joined, and the IoT portion, which was initially deprioritized, became reprioritized. And we made our first trial application for our mobile app. This took an entire month due to some issues with Xamarin that I'm sure Alan will get into. And lastly, we chose to switch from Ethereum to Hyperledger Fabric. Again, I'll let Eric talk about that. Moving on to Sprint 3, we had to ensure that we were able to create dynamic notifications. So we did that. I created a Node.js script that allowed us to send dynamic notifications. Then we set up our Hyperledger development environment locally. And then moving on to Sprint 4, we built a web server that had a web API so that we could send it some JSON and it would produce a dynamic notification. And so any component in our system would be able to call that and create a notification. Lastly, we attempted to rebuild the Hyperledger Fabric environment on Azure. That didn't go so hot, so we'll get into that later. Moving on, I'm just going to briefly touch on progress here for our mobile app. You'll see up at the top left there, I have a Postman client open. So this is running a post to our URL, and this will send a notification, as you can see on the next right two pictures. So we get a notification, and it contains the message that we initially sent to our web API. I'm going to pass it along to Eric to talk along the blockchain.
All right, so as far as the blockchain goes, a lot of people aren't really familiar with it, so we're going to cover some bullet points before we actually get into the progress here. So as you can see from the slide there, I've got about 4 questions we want to answer, and then we'll get back into it, because it makes a lot more sense when you actually know what you're dealing with. So what is blockchain? As you see from the slide, it's a string of buzzwords, and that's generally how it works. But no, realistically, it's like an over-engineered database, more or less. So there is a database at the very back end of it, except there is a lot of permissions, a lot of validation, a lot of networking that goes into basically the building of a blockchain. So that's what sets it apart. Any kind of data that's put into the blockchain has to be validated by every other peer that is a member of that blockchain. And if they don't validate it, it doesn't go on. If they do validate it, it's time-stamped, logged. Basically, you know, generically, you know who did it. So there's different types of blockchains, and we'll go into that in a further slide here. But in general, you know who did it, and then when they did it and what they changed. So as you can read on the slide, it's decentralized, distributed, more buzzwords and things of that nature. Everybody's got to validate. That's basically a blockchain. So how does it work? So as with anything technological in this world, people like to give it weird names so that it doesn't make sense to the common folk. In this instance, a transaction, which could be anything from money, could be data, could be physical assets, things of that nature, those are called blocks. It gets sent to basically a network. Those networks are individual nodes. So in different implementations, you have different node layouts. So we'll get into that in a different slide as well. Once the transaction's on a node, it needs to be verified by every other node on the network. Once the verification happens, that transaction becomes immutable. Pretty much all the data that's on that transaction will stay. So you can change the data in the future, but that transaction you made will always be viewable. You can always go back and query that information, see who made this transaction, what data did they change, all that fun stuff. So that's pretty much how it works. And then why blockchain? So when you're thinking about blockchain, you're probably thinking about people, oh man, I made my millions on Bitcoin, right? Why does a business care, right? They make money other ways. So the reason it matters for a business is mainly trust issues. So the way that businesses are currently structured, everybody has their own database. So everybody has to maintain their own database. There's overhead in technical costs that come along with that. And also, if you have a discrepancy between two entities' data, you're always going to have at least one unhappy individual. So nobody trusts anybody. Whoever's on the losing end of that discrepancy is always going to be rather upset, and they want to know why there's a discrepancy and who's at fault, and are they really the one that's at fault there? So that's why the blockchain helps. Having a distributed ledger on a blockchain, everybody has all the same data. As soon as a transaction is pushed through the blockchain, that data is distributed to the ledgers, and basically everybody agreed. So all the nodes, all the companies, they all agreed that that data was good. And if there was some kind of shenanigans going on there, they can go back, they see the timestamp, they see that Bob from company A did this on day A, he changed exactly this information, and then he can be held accountable for that. So now we get to the which blockchain part. So I'm not sure if you're all familiar, there's an entire stock market on blockchains. There are hundreds of these things. Two different types of blockchains in general. There's the public and the private. In general, your public blockchains are going to be things that have a cryptocurrency tied to them. They are mainly for financial transactions. although things like Ethereum, they kind of branch out. The private blockchains, they're more for enterprise data and things of that nature. So the main difference between them, a public blockchain that's tied to a cryptocurrency is in general going to have a fee associated with every transaction. So when we went with Ethereum to begin, the reason we went with that is because there's a lot of documentation. It's been out for quite a while, and basically it seemed pretty simple. And then we got into it and we noticed, okay, you have to pay a fee for every single transaction, and it's just some fraction with Ethereum, for example, of Ether, but it's still like $3 per transaction, and you have to mine this in order to actually do it. So what we would have had to do is fork the coin, make our own cryptocurrency, and then we would still have the very first transaction, you would have to pay the Ether to acquire our coins, which we could give you 1 trillion coins and you would never run out. But you still need the Ether for that first transaction. So that was a pain in the butt, and then, what if somebody happens to do 1 trillion transactions? They're out of coins. You need to re-up the coins. It just became kind of a pain in the butt. So we ended up going to Hyperledger. Hyperledger we really didn't know a whole lot about. So Dave was nice enough to kind of point us in that direction, and as it turns out, Hyperledger is a much better fit for this particular application. Reason being is it was built from the ground up for business applications. There is a business modeling language that they built for it, so you can have basically 3 tiers of users on it. So you can have your business users who like their reports and analytics. You can have your network administrators who divvy out rights, and then you can have your DevOps folks who set everything up and make sure it's running right and things of that nature. And they support test environments for all 3 of those, but that's also what causes a lot of complications. So we had a couple of criteria. First off, the blockchain had to be on Azure. So one of the big things with Azure is scalability. A blockchain on Azure is very nice and very scalable, simply because every company needs nodes. So basically you have 4 nodes for a minimum on a Hyperledger blockchain. Any company or entity that wants there to be included is going to need that 4-node minimum as well. And then as traffic increases, you can scale up the nodes to handle the traffic. So it's a very nice implementation. But basically we needed, again, to have it supported on Azure. So Ethereum was the main supported blockchain on Azure, which again, we were kind of ignorant in the beginning. We didn't know the terminology. And when I was searching for these things, I wasn't reading news articles. I was reading documentation. And of course, no documentation is going to point at the other guy and be like, oh, he's great for this application. So when I started, I thought everything was a cryptocurrency-tied blockchain. So ignorance was a big part of why this didn't come together in the end. But moving on to the progress, so the first sprint, of course, we started with Ethereum. That didn't pan out because, again, the implementation just doesn't work. There are people that are trying to get it to work. It's just kind of sloppy compared to other implementations. So that took a fairly decent amount of time, about a month, to figure out that we really are not going down the right path here. So we switched over to Hyperledger at that point, and then we deployed the 4 nodes on Azure. The Azure implementation was actually very simple to set up, although getting everything set up and then moved into Azure from the outside is not so easy. But on Azure, you have the 4 nodes, so you can see 3 of them there. You have the client, the orderer, and the peer. You have 2 peers per setup, so that's where your 4 nodes come from. The peers are what hold the chain code, which is basically what tells you, all right, these items need to change. It's basically where your scripts are held and executed, and the peers are also what come together and make a consensus to give, whether the chain code you're validating is valid or whether you need to throw it away. So we created the business model file. Basically, to do that, we had to set up an entire development environment. Like I mentioned previously, Hyperledger has a suite for basically 3 levels of business employees, and you have to go through every one of those levels in these files. So the model file, the .cto, is actually a modeling file, so that's what the business analysts would use. They would basically say, all right, here, well, they probably wouldn't write it, but they would have a lot of input in there. They'd say, all right, we're dealing with these businesses, we want the data to be structured this way, and things of that nature, so that eventually that could be sent off to analytics and they could generate reports and things of that nature. So that model file directly correlates to the chain code file, which is a JavaScript file. That JavaScript basically does everything that everything in a transaction. So if you need to transfer ownership rights from item to item, it would be in that JavaScript file. If you need to change data, if you need to do anything, it's going to be in that JavaScript file. And also the permissions file is obviously permissions. So Hyperledger is different than the public blockchain. In that public blockchains, you anonymously just make a transaction. It doesn't care who you are, it doesn't validate anything. If you have the setup and you submit a transaction, it's pretty much good to go. Whereas with this public block or the private blockchain here, you need the permissions because you can have different levels of users. Say you want Cindy from company B, right? Cindy is a filing individual. She does paperwork, things of that nature. She doesn't need to see the financials. She doesn't need to see various portions of this data. So you give her the permissions that you want her to see this. You want her to have right access to that type of thing. So in the end, we failed to deploy the BNA file, so it's a business network file, to the peer nodes. Reason being, to get to the point where you actually generate the business file, it's actually a rather long road. So like I mentioned, you need an actual development environment. Started out trying to install it on Windows, did not go well. It is made by the Hyperledger is a project by the Linux Foundation, so of course Linux integration would be easier. Me having some 10 years of IT experience, oh, no problem, right? I can get it working on anything. Not so much so. So ended up wasting some time on that, then porting it over to Linux, ran a lot better there. Problem with that is, at some point, so we had to rebuild this development environment twice. The reason we had to rebuild it, we had it on a local environment, so I have a Linux machine, so it was just on that. We were developing things, we got the BNA file all set up, and we couldn't migrate it to our production, which was the Azure nodes. Reason for that, Hyperledger is fairly new. It's some 7 or 8 months old, I want to say, and they update things all the time. So basically what ended up happening is our chain code wasn't compatible with our dev environment. Somewhere between then and now, the dev environment was upgraded to a point where the chain code examples that we were using to model this weren't compatible with our version of Hyperledger. So we switched over to Azure, basically got that set up and fixed the issue, but we ran into another issue that wasn't in the documentation, and at this point the documentation had been migrated, so they either changed hosts or they did something. But their GitHub account, as well as their general documentation, their website, pretty much everything that I had bookmarked or that I knew about was now leading to null sites. So they switched all at a big hullabaloo trying to find everything again. But basically, at the end, there are shell scripts. Those shell scripts do a lot of setup for each individual node because you need the IPs, the ports, the login credentials, etc., to actually get the chain code to run. And needless to say, kind of ran out of time at that point. So I pretty much mismanaged my time, invested a lot more time than I should trying to get this finished, and had a bunch of homework piled up. Basically shot myself in the foot there. So moving on, we'll move to a Keel here and the Internet of Things implementation.
So coming to the IoT part, we have a couple of hardware devices that we have actually used over here. So the first thing is the Raspberry Pi. As you all know, it's a microprocessor, and Raspberry Pi is one of the best microprocessors employed for the IoT applications and given its processing speed. And we, on the other hand, we have a temperature sensor, a DXC11 temperature sensor that actually detects the temperature and humidity. And whatever data is gathered by the DXC11 is sent to Raspberry Pi, which processes it. And and then we like store all the gathered data in the cloud, which will be seen in the further slides. Okay, so first of all, we generate the device credentials, and so device in specific is the DXC11 over here, and each device of course has a device ID and device key, which these two parameters vary from one device to the another device, and these two parameters will of course be used in the further operations that we actually worked on. So we were able to gather data temperature from the DXC11 and send to Raspberry Pi, and after processing we were able to store all the data on the Azure platform. And so whatever data was gathered by the DXC11 and processed by the Raspberry Pi was stored on the Azure, and we actually got it stored in the form of table. We could also store it in the form of a file or a queue. And so as you can see over here, we have a range of temperature values which are detected by the DXC11, and we also have a threshold value which was initialized to 30 degrees centigrade, and if the temperature was supposed to exceed 30 degrees centigrade, it was an error. We were supposed to display an error. So as of now, we have a list of temperature values detected by DXC11 and also a temperature value which is crossing that specified threshold. And instantly there is an error which is displayed, which is the temperature alert, saying that the temperature is too high. And so yes, so irrespective of whether the temperature exceeds that specified threshold or not, all the gathered data is stored on the Azure platform. And in case we have any value that exceeds the temperature threshold, we have push notification to be sent to the Xamarin. We were supposed to have that, but unfortunately we failed in actually we were not successful in implementing that part. So yes, I'll now pass it down to Alan.
As we move on to the issues and risks coming into this project, there's quite a few of technologies that we're not aware of at the time. We didn't have too much domain exposure. Azure Portal was fairly new and complicated at first until we actually got into it and started playing around with it. Xamarin, it's an awesome technology. It's cross-platform, so you can create on iOS or Android or Windows Phone. But we ran into some early issues with building just a simple app, or even getting the right emulator for that specific build. So there's quite a few times like we were trying to play around and uninstall or reinstall emulators, or go to a different Android that we were actually working on, like either go to Oreo or move down to Nougat. So after we eventually got over with that, and we were able to build our app and work on that. And also blockchain, its limited documentation regarding the Hyperledger Fabric, which gave Eric some issues with that. Also, I want to talk about the Azure Access. Microsoft has a 1 month free $200 subscription that you could rack up and use and play around with Azure and create different stuff. But just because our project was semester long, we couldn't really use that, because then we would have expenses on our part, and that's not really what we were aiming for. But our mentor Dave actually got a subscription for us, and we were able to build and deploy stuff on that account. So just some postmortem summary. We realized that research is super helpful, and done right can lead to success. Understanding the concept is not enough. You need to know where to find it. So documentation is always helpful. Watching tutorials and implementing on what that person did on the tutorial to our own specific needs, and being able to adjust accordingly. And also ask for help. Like if you are can deploy something or can't get to work, ask for a new or just a fresh mind or a new set of ideas that can actually help and help the project go forward. And this diagram at the bottom of the screen, it's our current architecture that we have at the moment. Since we weren't able to get the IoT portion implemented with the project, we have a similar device that reads a certain number of values and then calls a function that calls the API. So if we had more time, we would like to implement, of course, a Hyperledger Fabric, because I think that's the backbone of our project, being able to exchange secure data from the businesses. all the time. We would like to upgrade our mobile application so the user interface is not so plain just to receive a notification. So the project manager or let's say the pizza store manager can go in and be able to manipulate some data. And also we would like to implement the IoT device, since it's an awesome technology where you can just have different devices that read different temperatures and it all comes back and be connected on Azure. And that concludes our project. If you have any questions, we'll be happy to answer them.
I'm trying to absorb everything, but okay, so the blockchain, I kind of understand the issues there. And I guess on the front end, the hardware isn't working or something? So.
Well, the hardware is actually working, but we were not able to pretty much, integrate the IoT part and the Xamarin part.
Okay, those parts never got.
Yep.
Because I didn't see the prototype of the mobile app either. Was there something built on using Xamarin that was showable?
It's on my phone. We just didn't want to fire up the dockcam, and we were initially intending to have the IoT device sense the temperature beyond 30 degrees centigrade and then fire off a request to the web API that I've set up. That just didn't happen, so we just kind of scrapped our demo.
There is a demo of the blockchain portion if you want to see it, but see that we're kind of shooting the time here, so.
Thank you.